So we're starting 10.4, which is going to deal with two different types of exponents. We've been dealing with positive exponents, and so one of the main questions then is, what if the exponent is 0, and what if the exponent is a negative? So we're first going to talk about a negative. Now, let me just kind of refer back to what we did, like when we had like x to the power of 4 over x to the power of 3. In order to simplify that, we would subtract, right? And so the exponents would subtract, and we would have x to the power of 1, or just x, right? Now, what if we had, instead of that, if we had like y to the power of 2 over y to the power of 7, let's say. So in this case, we actually have the numerator exponent is smaller than the denominator exponent. We haven't really seen that before. But if we were to do the same thing, subtract the 2 minus 7, we end up with y to the negative 5 power. Y to the negative 5. Now, I want to see what is y to the negative 5 power really the same thing as. So in blue, I'm just going to kind of, expand what I have in the numerator. So if in the numerator I have y times y, and then in the denominator I have 7 of these y's. I know I ran out of room there, but and remember what we did is, like, we would try to find a pair from the numerator and denominator, and that would cancel, and find a pair that would cancel, and then we would write what's left over. And so what's left over here, we see that in the numerator there's not really anything, but in the denominator I still have y to the 5th power. Now, numerator, there's nothing there. It's not 0, but when they cancel, it cancels out to 1. So y squared divided by y to the 7th expanded cancels out to 1 over y to the 5th. When we did our shortcut, we got y to the negative 5th. So this and this are equivalent with each other. A negative exponent can become positive if it moves to the denominator, or if it moves to its other side. So I'm gonna kind of if we start our first page of the notes, it'll kind of show what the rule is there for negative exponents. Here again we have like an example. 4 to the negative 2nd power is the same thing as 1 over 4 to the positive 2 power. Okay, so in order for a negative exponent to be positive, you kind of bring it to a denominator in some sense. So example 1a, 3 to the negative 4th power. If I wanted to change that, then I would, this 3 to the negative 4 would become positive in the denominator, and then in the numerator, since I don't really have anything, I'm just going to kind of put a 1 there. So that's how it becomes positive. Now, 3 to the 4th, we actually know that, so I'm going to evaluate that. 3 to the 4th, if I were to use a calculator, is 1 over 81. So 3 to the negative 4th power is the same thing as 1 over 81. For part B, I have all of negative 8.5 raised to the negative 4th power. So you know what? I'm going to change this right now to 1 over negative 8.5. And keep in mind, the base doesn't change signs, only the exponent. So 1 over negative 8.5 raised to the 4th power, and then this second one is just already a positive exponent, so I don't really have to do anything there. Okay, so that's what I have. Now, this second one is really a numerator. So 1 times this negative 8.5 raised to the 4th is the same thing as negative 8.5 raised to the 4th divided by, and then now I have that denominator negative 8.5 raised to the 4th power. And then so I'm going to simplify that. I recognize they have the same base, so then I'm going to subtract the exponents, and so I get negative 8.5 raised to the 0 power. Now, we actually didn't really talk about the 0 power, so I'm just going to kind of leave that there, just to show you the definition of the 0 exponent. I know that we're going to get to that a little bit later, okay? Example 1c, I have 2 to the 6th power over 2 to the 8th power. Now, if I were to subtract 6 minus 8, I get 2 to the negative 2nd power. But this is not simplified because negative exponents aren't simplified. But I know that I can make it positive by putting it in the denominator, putting a 1 over it. Now, 1 over 2 squared, that's really the same thing as 1 over 4. I know there are all these lines and stuff here. We could just kind of ignore all that. If you need to kind of pause and rewind the video just to see what kind of happened, feel free to do so. There are a couple of on your own problems. I know these negative exponents are a little bit tricky, but I would like for you to try the on your owns. So please take a moment, try your best with these, and then I'll go through them one by one. So I did numbers 1 and 2 there. To make a negative exponent into a positive, I just need to bring it down to the denominator, and that's what I get, and then I can evaluate it. Number 3, I do have a negative exponent here, but honestly, I can do one of my old rules. I see the same base and they're being multiplied, so what was the shortcut that I do with the exponents? I add. So 6 raised to the negative 8 plus 8 is just 0. So 6 to the 0 power. Again, for now, we haven't technically talked about the 0 exponent, so let's just leave it like that. In a little bit, after you learn the 0 exponent, you will kind of know what the answer to that is. Number 4, let me give you just a little bit of a trick. Okay, number 4, you don't technically have to do numerator minus the denominator, 5 minus 6. You can do the bigger minus the smaller, but you just have to keep in mind where is the bigger number, and then that's where the positive exponent leftovers will be. So my bigger exponent is in the denominator, so I can do 6 minus 5, which is 1. And so since the bigger exponent was in the denominator, my leftover exponent is going to remain in the denominator. So that's number 4 there. 1 over negative 3 to the 1st power, or honestly just 1 over negative 3. Number 5, again, I do see a negative exponent, but instead of bringing that down, I can just go ahead and do the shortcut that I know here. Right, I see the same base, they're being multiplied, so I'm going to add these two exponents. 5 plus negative 3 is a positive 2, and then I'm just going to kind of keep this 2 here. And then I have 4 squared divided by 4 squared. Same base, so I'm going to subtract the exponents to get 4 to the 0. Again, I have no idea, not yet at least, what happens when I have to the 0 power. I know the on your owns were a little bit tough. If you do want to rewind that, you definitely can. Okay, here we get into the 0 power. Right, here I have 5 to the 3rd divided by 5 to the 3rd. Now this middle rule is like, they're the same base, so I know I'm going to subtract that, right? So I get 5 to the 3 minus 3. Now, instead of doing that, if I were to expand 5 to the 3rd over 5 to the 3rd, I get that. And then these pairs cancel, these cancel, these cancel. Now, when I say they cancel, they don't cancel to 0, but they cancel to 1. And so this ultimately equals 1. So 5 to the 3 minus 3, which is 0, is the same thing as just 1. 1 is my final answer. Try filling in the rest of the table and then pause. Once you finish it, you can take a look, press play, and then you'll kind of see my table filled out as well. Here's what I got for my table. Everything always canceled. And it kind of makes sense, right? If I have the same number of bases in the numerator divided by the same number of bases in the denominator, then everything cancels. And so when they cancel, they get equal to 1. Now, the shortcut, if I were to subtract the exponents, I do get 0 as an exponent. And so anything to the 0 power is equal to 1. So I just wrote like a full sentence of what I've noticed. The numerator and denominator always completely cancel each other out to 1. So then part C, the question is, how can you use these results to define a to the 0 power? A to the 0 power will always equal 1. Anything raised to the 0 power will equal to 1. So that's what it kind of says in this little definition here. A to the 0 power is equal to 1. Anything is equal to 0, or is equal to 1, okay? Now, example 2a, you do have to be careful though. What is the exponent touching? So in letter A, I have negative 5 as a base times x to the 0 power. This x to the 0 is equal to 1, and so really you have negative 5 times 1, which is just negative 5. So be careful that negative 5 is not affected by the 0. Because what I mean is, like, if you have negative 5x in a group raised to the 0 power, then actually this whole thing would equal to 1. But that's not what we have in example A. Okay, so negative 5 is my final simplification here. Whoops. Now for B, I have 9 times y to the negative third divided by y to the 5th power. I see the same base. This 9, I'm going to kind of keep it separated, okay? But I see the same base, the y's, and so I'm going to subtract the exponents. I'm going to do negative 3 minus 5, and so I get 9y to the negative 8th power. Now, negative 8th power, that's not fully simplified, but that only affects the y because that's the only thing that exponent is touching. And so this 9 is going to stay in the numerator while the y to the 8th power will go down to the denominator. That one may be a little bit confusing there, but it's because that y is the only thing that negative 8 is touching. If you want to rewind that, that might be a good idea just to kind of watch it again. Otherwise, I'm going to ask you to move on to the on your own parts. So I want you to try these 3 questions on your own with all the knowledge that we've been doing, and then pause the video while you're trying it. When you're ready to check your work and see if you're correct, you can press play for my explanation, and then that's it for our notes. So here I just did the first 2. Number 1, again, that negative 2 exponent is only touching the x, so only that x will go to the denominator, while that 8 stays in the numerator. Number 2, I showed a little bit of work. You don't have to show nearly as much work, but I wanted to show you that I'm using the shortcut of adding the exponents because I have the same base being multiplied. 0 plus negative 10, which I got b to the negative 10th power. And then I know that negative exponent can be positive when I bring it down to the denominator. And so I have 1 over b to the positive 10. Now, I did want to do number 3 together. z to the 6th divided by z to the 9th. Same base, so I'm going to subtract. Now, instead of doing the numerator minus denominator, I talked about this earlier in the video, I'm going to do bigger minus smaller. My bigger exponent is in the denominator, so that means it's going to stay in the denominator. And so 9 minus 6, that 3 is going to stay in the denominator. That 15 is also, I didn't do anything with that 15, so that's going to stay there. Now, what's then is in my numerator? It's not 0, but my numerator is just going to be 1. So those are the on your own problems. I know there's a word problem at the end after this, but I'm just going to kind of skip over that. These are the two essential learning targets I want us to be okay with as we move on and finish off 10.4.